Hi, this is Jeline from the Honors Tutorial. Our topic for today is about simplifying radical expressions. This is under Mathematics 9. So let's have here our example number 1. This is the square root of 9, a raised to 4, b raised to 7, c raised to 21. And since we are talking about the square root, let's have 9 first. Just think of a number without having a calculator. Just think of a number that when you raise to 2 is equal to 9. And that is 3, right? It is because 3 raised to 2 is equal to 9. 3 raised to 2 meaning 3 times 3 because your exponent is telling your base how many times are you going to multiply the base to itself. And that is twice because the exponent is 2. So 3 times 3, that's 9. So for our answer, we will be getting the base only. So we have here 3. And then for our variables, let's start with a. So a raised to 4, the exponent is 4, right? But the index here, though we cannot see it, but there's 2 here. So what are we going to do is to divide 4, the exponent of a, with 2, which is our index. So 4 divided by 2, that's 2. So we have here a raised to 2. This is outside the radical symbol. Okay. Next, let's have b. For b, same process. We will be dividing the exponent of b and the index. So 7 divided by 2, that's 3, right? Remainder 1. So that's 3, remainder 1. So for 3, we will be writing it outside the radical symbol. Then it will become b raised to 3. And then we will write a radical symbol here. And then we will be putting the remainder of b. So that's b raised to 1. And then after that, we will be solving c raised to 21. Same process, kindly divide 21 and 2, the exponent of c and the index. So 21 divided by 2, that's 10, remainder 1. So 10 will be outside, so that's c raised to 10 here. And then our remainder, which is 1, should be inside the radical symbol. So this is our final answer. And we have here 3a squared b cubed c raised to 10 square root of bc. Let us have another example. And this is example 2. We have here the cube root of r raised to 8. Same process. We should divide the exponent of r and the index. And that is 8 divided by 3. That's 2. Remainder 2. Because 3 times 2 is 6. Remainder 2. So we will be putting this, the whole number or the quotient 2, outside the radical symbol. So that is r squared. And then we have here the cube root of r raised to 2 since our remainder is 2. And this is the final answer. Next, let us have another example. For number 3, this is the square root of 90 q raised to 10. I want you to think of factors of 90. The first factor is a perfect square number and the other one is not. So in this case, for 90, let's try 9 times 10 because 9 is a perfect square number and 10 is not. And then times q raised to 10. Please don't forget to extend your radical symbol until all of the terms is covered by the radical symbol. Because if it is not covered by the radical symbol, then meaning it is not included in our radical symbol. It is outside. So let's solve. What is the square root of 9? That's 3. So we will be writing 3 here outside. And then for q raised to 10, we will be dividing the exponent 10 to our index, which is 2. It's here, but it is invisible. So that's why you cannot see it. And I'm just writing it for you to see it. So 10 divided by 2, that's 5. That's q raised to 5 outside. And we don't have any remainder, so therefore, we will not be writing q inside the radical symbol. For 10, it is factorable, yes, but there's no number that is a factor of 10 that is also a perfect square number. So we will be writing square root of 10 here. Because, for example, if you think of 5 times 2, 5 is not a perfect square number and also 2. So therefore, we cannot simplify it anymore. And this is the final answer, 3q raised to 5 square root of 10. For number 4, let us have other example. For example number 4. Let's say that we have here this. Let's say that we have here the fourth root of 80 AB raised to 8C. Okay. So for this kind of given, this is what I want you to do. I want you to factor 80 and then think of factors if possible only, okay? Think of factors. The other factor is a perfect number, that is when raised to 4 and multiplied to another number is equal to 80. So we can say that we have here the fourth root of 16 times 5. 16 times 5 is equal to 80, and 16 when converted into exponential form, it could be 2 raised to 4 like this. So that's why it is possible to have 16 here. Next, we have here A times B raised to 8 times C. So the fourth root of 16 is 2 because 2 raised to 4 is equal to 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's why 2 is the fourth root of 16. And then we will be having here this fourth root of 5 because there's no fourth root of 5 that is a whole number. When we simplified it, then it will become a decimal number. Next, how about A? We cannot get the fourth root of A here because the exponent of A is 1. 1 is less than your index, so therefore, we cannot divide it. Next, for B, it is possible to divide it because 8 is greater than your index, which is 4. 8 divided by 4, that's 2, without remainder. So we will be writing b raised to 2 here. And then for c, the exponent is 1. So again, it is not possible to divide it by your index because 1 is less than 4. So therefore, we will be writing c here. So the final answer is 2b squared, fourth root of 5c. So that's it for our topic for today, which is about simplifying radicals. I hope that you have learned something. If you have further inquiries about the topic or about us, you can message the FB page of the Honors Tutorial. Thank you and God bless.